Well. I have returned today for another great episode of learning graphics programming. Oh, I have to change the title to rewriting my GLF code back to winit. Because W is not that good. Okay. So last stream, let me open our project real quick. We did some stuff. Let's quickly run this. And also let me move this wire. So it's not an... Okay, what is this? Okay, like this. So last time we finished... Oops. What's this? What has happened? Oh, yep, I'm gonna cover what that is later. So if you run right now. Oops, I forgot to toast turn on music. Let's see this and shuffle play. Why is it so quiet all of a sudden? Okay, I think this is good. So let's see. Hello, Mr. Ojen. Wow, you're so hilarious. Hello, Zook. So last time, I showed me how I rewrote my winit application to use GLFW, and I got something. I mean, not something. It's absolutely the same. This time it just uses GLFW. But there was a small little issue with this program. First of all, if you can notice, I start holding an input and it first moves and then it stops, and only after some time it starts moving again. I'm gonna fix it by probably adding an input library and using the input library rather than the input which is built into the project. The second, press Alt Z right now. That is like that blog. What do you mean press Alt C? What is Alt Z? I'm scared. Oh, that thing. Yeah, I do have it. I do have GeForce Experience. I don't even remember why I installed it. I think it comes by default. I don't know though. So the big problem, I mean, like, this can be fixed, the movement, but look at this. Resizing it like this, it's fine. It's still nice and smooth. But if I resize it like this, you're gonna, like, look at the square, how it's moving right now. And look, first of all, these black spaces appear. The program fully stops. I stopped holding already. And it's like a full second and a half. And the same goes for doing it smaller. And in my opinion, this is a very big problem. And the reason I decided to switch to GLFW in the first place is because I couldn't figure out the solution. Wait, I can make it wider. Like this. Okay, so the solution, the problem I had was I couldn't do update loop. Like, I just couldn't figure out how to do it. So yesterday after stream, I found this issue with scaling, and I thought that, like, maybe there's a good way of fixing it, but it seems to be a GLFW issue. So, sadly, we're gonna be going back to winit. So, the last 2 hours of my last stream are absolutely useless. But, at least something is gonna change today. Because instead, let me first show this. Let me close this. Why did it not? Okay. Because instead of using run app, we're gonna do run on demand. Basically what this allows us to do is make a loop, something like what we do in GLFW, and it's still gonna keep all the functionality. I'm not very scared of doing this right now. It's probably not gonna take a while because I haven't actually deleted any of the code I've made. So yeah, it should be fine. So let's quickly get to doing it. It's probably gonna take a few minutes or so. First, let me do this and delete this. Let me, just in case, maybe I'll use it. I don't know. I switch really often from like library to library, which is not a good thing. So let's see. Then we do this. What? I need to delete this. Failed to just import. Okay, let me just remove all of this from here. Failed resolve and what? Okay, let me quickly restart. Usually restarting Visual Studio Code fixes some of the issues. Let's see. Let it load for a few seconds. Can you give me a number between 1 and 100? 48. Okay. Import this. Import this. Winit. Okay. First let's fix all the issues here. Oh, also comment this out, I guess. Okay, fix all the issues here. I do not need this. Then we go to state. And we're going to be changing a lot. And I mean a lot of stuff here. First of all, we're going to be using just an arc pointer to winit window. Just do window. It's going to guess it. Yep. Then we're gonna be using size. We're gonna be doing, actually I'm gonna keep it like this, it's fine. If I can do window width, window size. Okay, I guess I'm gonna have to be doing physical size. That's fine. I just have to change a few variables. Physical size, CQ32. And set the size to window.inner size. So creating surface, we're going to be doing from arc. Oh, we don't create an arc window here. Okay, wait. First we need to create that, of course. Let window arc be equal to a new arc from window. So then here we're going to be using window arc.clone.inner size, and also we're going to be using new. Okay, we delete the instance arc. We're going to be using just the instance. Let's see, where am I using arc instance? Yep. Remove this. Also remove the entire function which needs it. Where is it? Update surface. Yep, we do not need this anymore. Let's see. What else do we not need? Let's go by errors. First of all, it has to create instance, create surface. Oh, remove the clone. Create surface, and it's gonna take our window arc. Dot clone. Okay. We can just use our instance here. What? Oh, misspelled. Wait, is this also misspelled? No, it's not. So size, create surface config. We're gonna be taking physical size here. E32. Width, height. Okay, let's go back up. Let's see, so here, let's remove the arc. We do not need it anymore. Go up again. This is gonna take like 10 more minutes probably. Okay, no errors, no errors. Where could there be errors? Oh, in resize. Oh yeah, I was right. Physical size U32. And this is gonna be width, and this is gonna be height. There are 2 more errors somewhere. Where could they possibly be? Maybe at the top in implementations? Nope. Oh, yep, in returning. So first we just need to return our instance, but we're gonna return our window arc here. What this also... Okay, I'm gonna fix that later. What this also allows us to do is make this static. So we can remove this, we can remove this, we can remove this, and we can just send a normal window here. Okay, that fixes that, I guess. Oops. Still a problem though. Oh my god, stop. Use of, oh yeah, we also don't need to save the instance anymore, as we're not going to be using it for updating our surface. Okay, so now in our app, let's go to the input function, which we commented out. Uncomment this. Element state. And import this. Expected 2 arguments. Oh yeah. In input we're gonna ask for camera as well. That we can send here. Let's see, let's go back to app and process input. Actually, yeah, we don't take an argument. We can just send our own camera. Self.mutable camera. Yep. This. Okay, sorry, I got 73 instead. What do you mean 73? What? I don't get the what? Huh. I'm confused. Method takes 1 argument. Okay, we're gonna comment this. Actually, no, I cannot comment this out. For now, let's just go to our update function. Remove this, remove delta time, and just set this to a very low number, like this. Oh, 5. Let's see. So app, remove this, not needed. State, let's see, maybe some implementation. Yep, we do not need this. We can just take everything from camera. There's another one. Oh, why does it not show up here in the edge? Oh, because... Wait, let me... this window. Oh, now it shows it. Oh, I guess I kind of scaled the window incorrectly, so... Okay. So it shows it right here at the bottom. Oh, okay, I know that. We're gonna leave that there for now. Oh, well, you said 48, but I got... What do you mean you got? Got on what? What was the thing that... Like, the thing? SFW. Oh, okay. How dare you do something like that to me? How did I do it? Let's open the actual learn winit thing. What? I pressed 11 by accident. Winit. Oops, not winit, but GPU. Learn. Okay. Let's go to camera. Okay, how did it do it? Key code. Key W. Expected dot physical key. Hey, what if I do logical key instead? What type is this? It's still key. So if I do key small string, this has two use cases: allows scoring whether the current input is a dead key, allows handling key bindings on platforms which don't support okay, it doesn't really matter what we're going to be using. We're still going to change our input system to use input library. Okay. Change this to be S. Copy this here, copy this here. This is A, this is D, and copy from here to here. Yep. All of this should technically run the same. No. Yep. Instead, the input is not working. Oh, yep, that is what we're going to be doing now. Okay, so the thing that I wanted to change. Let me go full mode because we're not going to be needing any documentation for this. So what we're going to be changing is we're going to have process input. And what we're also going to be doing is we're going to be setting our wait, what parameters does it take? Event. The shift key overrides numlock. In other words, while shift is down, numpad keys active numlock wasn't active. When this is used, the OS sends fake key events which are not marked as okay. Device ID, yeah, we only need event. So this is a key event. For our app, we're gonna add public current key. This is going to be our key event. So what we're going to do is we're going to create a trait app functions. There's going to be a function input which takes in immutable of self and a key event, so key event, and another function update for immutable self, key event, oh wait, nothing here. So now if we go here, we do implement app. Can I just choose everything from here? So implement app. Oh, I need to make it a public trait. Yep, my mistake. Style, what beats paper? Think of something creative. Water. It's not very creative. A dinosaur can. Okay, for now let's move to this. So implement app functions for app. Can we do this? Yep, function input and function update. Okay, we can do this. So we're not going to be, what we're going to do is we're going to create a main loop here. It's going to be, okay, for this I am going to need documentation. I forgot how it's done. So we do event. I also need to set in new edx. Is this something? Okay. I don't need that. So event loop.run app on demand. My app mutable. Let's also comment this out. Can only be used that returns. Yeah, sure, this can return nothing or error. Oh, result, not return. And this is supposed to be mutable, as we are going to be changing it. Are there any errors here? No. There should be. Oh, that's weird, but okay. Still, check DMs. A dinosaur beats paper. A dinosaur would probably stomp on paper unless it's a vegan dinosaur, but that's not a thing. It is a thing. Great minds think alike. 26 other guessed this too. Oh, you meant like by creative you meant stupid. Okay. Not stupid, silly. Yes. He's typing fast, it's great. Yeah. Fast typer. What beats what? What beats a dinosaur? A paper cut. What? Oh. Oh. Silly me. So self and current key is none. And also here, I'm going to be setting self dot current key to event. So. Well, okay. Let's see. Let's run this again. Let's clear this first. Okay, it runs. So what we can... Oh no. Oh no, what have I done? I made a virus. No. No, okay. How do I control C? Okay. Yeah. So what I can do, if event loop dot closing, if app dot, huh? Is it exiting? Do I need to get the active event loop? Let's see, if active event, wait, if event dot exiting. No, I'm just gonna add a boolean. Public closed boolean. And I can just set this to false. What I can do here is in window events. Actually, no, I'm gonna do it here. I'm gonna get self dot current key if self dot current key is equal to physical key dot code key code escape. Should be key escape. No, just escape. Okay. We set self dot closed to true. Expected enum. I'm gonna unwrap this. Okay. Is none, then we break. Why can't I break? Break outside of loop, outside of a loop or label block cannot break. Main. What? Wait, I can do that. Wait a second. If I go to input, first of all, change this. Second of all, remove this. Third of all, I cannot just use break. Yeah, I'm not inside a loop. And the block is gonna be this. No. Okay, this doesn't work. So if it's none, I just do return. Okay, yeah, that is okay. So now we can easily unwrap this. Expected key event. Oh, dot physical key. Key code. Why would I need to clone here though? Oh, this is a if statement for to check if one key was pressed. Okay, and then I'm gonna see if app.closed, then we're gonna break from our main loop. Oh, and don't, of course, don't forget the OK. So now we should be able to escape. Oh, we're not gonna be able to do that because first we're gonna need to do app.input. Is this actually gonna work? No way in hell this is gonna work. Yeah, I sort of expected that. I gotta go have a fulfilling. Okay, you. Bye. Oof. Okay, let's close this. Let's go back full screen. Let's delete this, we don't need that. Let's delete all of this actually. I can rewrite it anyways if I need to. Which I'm not gonna need to, because I'm gonna figure out a way why this is not working. Let's do some print statements. Print, print line, debug line, current key. Oops, clear. Okay. Cargo run. Let's see. So it doesn't print out anything. Amazing. So it's not even running. What could be the problem? What could be the problem? The function doesn't even run. If app okay, let's print something random. Does it just like not run in general? seems to be that way. Also, let's quickly go to our model. Find that print statement. Where is it? It's not on model. Huh? Maybe it's in resources? Yep. Delete it. Let's see. So I implement app functions for app. Why isn't it working? Calling functions implemented in traits Rust. So we have a trait self. Oh, do I need to do app functions input on app into variable? Oh, this. Okay. Oops, wrong thing. Go to my app real quick. Let's see. Exiting. How do I request event loop.request? Nope. Window.request. Nope. Event loop.exit. Okay, so I'm gonna have to implement. Let's see. Okay. So this is gonna be a private or public. I'm just gonna make it a function, public function close. It's gonna do event loop. It's gonna be an active event loop. We're gonna be creating self dot event loop. It's gonna be equal to arc new from event loop, and then we're just gonna use the event loop. But it's not being used anywhere. Oh wait, no, it is being used somewhere. Why can I not dereference it? Can I just... No, I can't. It's not gonna work. first let's set event loop to none. Okay, so I guess I'm gonna be having a lifetime. So it's gonna be a lifetime A. Let's see, we're gonna have to implement this here and implement this here. Nope. Oof, so it's keyword input. What? Oh yeah, I should remove this, 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 and this. Okay, let's see. So if I close, yep, it closes. That's good. No. Let's get into the event loop.stop, set control flow. Nope, event loop dot close, exit, escape, break. Nope, that's not the one. I'm writing the input function. If there is a key, then it's gonna check if it's equal to escape. That case, it's gonna set close to true. Then it's gonna break from here. How do I go about closing the actual app? Doesn't seem like it does anything here to do that. So what should work is a simple check to do this. So in this case, oh, this doesn't seem to work. Wait, maybe it works if I do double tap, right? So I press skip and I press it again. Nope. physical key. You gotta see. I need to have access to the event loop somehow. Okay, let's try again. So we create an event loop, which is a reference static actually. Now it's gonna have to be. Oh, I can't because I need to do arc. Can I do arc on a reference to the active event loop? Probably no. Yep, it's gonna need a lifetime specifier, sadly. Let's see. It literally says I want what? Okay, what beats a paper cut? What is this game? I want to play it so much. Okay. So. Wait, can I do this? Okay. Fine. Can I? Man. Let's see, maybe there's some more examples on this. Pump events. Let's see, what is this? Okay. Pump loop. Yeah, that's what I want to do. So event loop pump app events. So let's go here. Event loop dot pump. Wait. We set pump app events to set this to none, and this are going to be mutable reference to our app. So it pumps the events. What does this return? Pump status. Okay. Pump the event loop to check for and dispatch. Okay. So I guess it's good to set this to 0. What does this do? Let's see, let's just copy this whole thing here and paste it here. So first let's implement all of this. Exit code. Oh wait, this is just a break function. I'm just going to be breaking the main loop. Still opens a new window. I do not like that. So let me close this. Wait, does it actually open 2 windows? Nope. It was just that line. Man, this is so annoying. How would I get this event loop? If I think it's better to do it like this. Oh, what I can do though is, it's not gonna be a good idea though, isn't it? Huh. Let's see what other window events there are. Close requested. Okay. I don't know how useful this could be though. I really want to make a list where you can put all of your events in. What is new event? Let's see. I saw this function. Function new events. Come on. Hi, Nakomi. Yeah. I am trying to figure out some programming stuff. I hate this. I really just want to continue doing normal programming, but this is like so painful. This used to work fine. Now it doesn't. Why? No goddamn clue, that's why. Let's see, does it work? So instead of this, for now, self.process input. Yep. It does that funky stuff just because I need to set the closed to true. It does work here. Also, close that up for now. Oh my god. Okay, I'm just gonna continue this normally. I'm not gonna bother with any of this right now. So let's see all of this updates, that calls that function. For now, let's disable this. Just do up. Just do app update. This should work, right? It has all the. This escape works. Let's see, input. For the last 8 hours I'm playing Stone Block 3, by the way. That is not a good thing. How's it going? 8 hours is quite a while. You probably already beat it by this point. Why don't my keys work? It goes process input. Self.state as mutable unwrap. Goes input. Here if event state. It does read them. Then instead send stuff here. First let's remove this so we don't need it. What might be happening is we're just not updating the camera. Nope, we do update it. So I don't know what's up with that. man, I really feel like quitting this right now. I just can't. I want to go to a simpler language, even though Rust is amazing. I'm hating every second of winit right now. Maybe it caused this update. Let's remove this implementation for now. Let's remove this trade, just in general. Why can I not call the function? Will this work? Let's print line of app dot state dot state dot okay as mutable dot camera. Nope, state dot. Is it a private value by any chance? Let's see. Nope, it's public. Oh, because this is a okay unwrap camera, and let's say X, for example. What's wrong with this? Probably just clone. Yep. Or no. Maybe I should use clone on here. Okay. I don't need it as mutable, just as reference. So does it do anything? Oh, it doesn't even print out anything. So it doesn't even get to that line. Why though? It runs the app on demand. Maybe here. Nope. This stops the thread. What? How did it work before then? I'm so confused. Run the application with the event loop on the calling thread. Unlike event, this function accepts non-static closures, and it is possible to return control back to the caller without consuming the event loop by using exit. And so the event loop can be rerun after it has exit. They need to do event loop.exit. That will just close the window, right? I'm right, right? Oh, that's a thing that happened. Okay. I can't do that. So okay, maybe this is just a non-value, which would make absolutely no sense. Nope. It is just not printing anything. Because this is blocking the loop. Let's see, event loop.run app, and it just does that. If it's not a web platform, how does it do something like that? How does it pull off this code? How does it put on... Oh, two main functions, okay. And then it does implementations here? Come on, that's just BS. What is not... Oh my god. Let's see again. Just everything would be fixed if they just added an update function here. That's it. That's literally it. But no. Try to figure it out on your own, sucker. Okay. What if I comment this line out? Will it still print out anything? Nope. Oh my god. This is really stupid. What do you mean finished first loop? What is the loop? Do I have an infinite loop somewhere here by mistake? Oh my god. I wish there was someone who can explain to me right now. Event loop. Okay, so run on demand does not do what I expected it to do. Can I increase this? Nope, not like this. Can I just make this more visible? Nope, I cannot. Why does it have an event loop here? An event loop here, 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 and an event loop here. Okay, my second solution to this whole entire problem is just using an older version of winit, where the code is way much simpler, as you can see. But again, I have a very strange feeling that I cannot do normal update stuff here, that it will only... Can I just do this? Wait. I think it says that it was like deprecated or something, but I don't care anymore. Event loop.run. Let's just copy this. Okay. Let me quickly delete all of this. Let me quickly comment all of this out. And let me go to my Tomo file and change this version to 0.29. So now, this will be commented out. We already initialized senflogger, so you can just copy this out. And paste it here. Some stuff we have to implement. So let's see. Now that we switched to an older version, how does this work? So we have an event. I guess I'm gonna make this a little bit more readable. like this. If we do print line here, something like this, statement, so I need to add extra semicolons for it to become a block. How does this work? Does it print it every... Okay, it does. Okay, this is good. So, what I can do now, because it's going to change a bit, I guess, in the surface. Where are we drawing? Okay, yeah. Window, close requested, yep. We create our state. Use of moved value. In comparison. Okay, wait. Let window arc. Oh, I can just use the window. Where's the window? Window. So I just do state dot window. Yep. Okay, that fixes it. We also need requested resize. So window event, let's see. Let me separate. Okay, no, I'm gonna separate into functions later. Resize, yep. Everything's still the same. Actually, no, it's not the same. Redraw requested. Okay, let's do copy this. Oh, this is supposed to be here. Where is this supposed to be? What? matches the event. Okay, let's just go to the code. Oops, that's not the code. This is the code. Lib. Wait, was it lib? Nope, it was lib. Just go here and copy this beautiful thing. It's not beautiful, it's ugly as hell, but okay, so we do that. Okay, I guess I had some problems. Okay, so we set up all of this. Now let's quickly make all of this a bit better. So this is the rendering. Let's just close this. Resizing, yep. Oh, that's control flow.exit. Okay, so let's remove this. Do this and paste this here. It's gonna do the input function where it's gonna pass in our control flow and our event. No, it's gonna pass our state and physical key. Then we create our function input, which takes in control float. Control flow is reference event loop window target nothing. Okay, then we take our state, which is state. We take our physical key, which is of type physical key. Yep. That's weird. Why can I not find it? I'm just gonna do event. Just pass in the whole key event here. Yep. And oh yeah, okay, yeah, event. And replace this event and key event. Is this a reference? Yep, it's a reference. Okay. Not okay. Expected reference, key event. found reference window event. Okay, comma. Just forgot the comma. So now check if event dot physical key. Didn't you do some unwrap? Nope. Is equal to key code key escape. Then we're gonna do control flow dot exit. Okay, this works. This is good. We've made this a little bit more simple to read. Let's see. Can we now call our input function? No, state. Oh, I also need yet to pass in our state. It's a borrowed mutable reference. So it's going to be state. Yep. Oh, why did I say self? State. Because in one argument, which is going to be our event. Let's rename this to key event. It makes more sense. Copy, paste, paste. So this function gets called. Let's go to our camera. And then here, we're gonna check for event.physicalKey with key code. I just close this, key code, W. Yep. This is S. This is A. And this is D. I probably need to implement all of them. Amazing Strawberry Jam collab music. Expected physical key found key code. What did you expect physical key? This seemed to work. Okay, fine, I'm gonna return it. It worked fine like this. Wait, how is this rotating? Where does it call the update loop? What? Somewhere here? A redraw requested. I'm stupid. No, I'm not stupid. No, I am stupid. I could have used the same thing in app system. I don't care, I like this more. Okay. So, we're done with this, finally. I am not gonna be touching this for now. At all. I pushed through my stupid little brain. And now I can finally close this. Close this. Oh, it feels so nice. And we can continue with making lights. Oh, this feels nice. Everyone who is watching, go get some water break. Yes, it's very important for your health. I'm gonna do that as well. I have returned. I also grabbed a cookie. The cookie was very good. I'm really liking the cookie. Okay. Ambient lighting. Light has. Oh wait, I need to retitle my stream. Okay. The ambient part is based on the light color and the object color. We've already added our light bind group, so we just need to use it in our shader. Let's see where we're adding in this, just so we can keep. Also, let me just delete all of this. Actually, should I? No, I'm gonna keep it there for now. Let's see what's useless though, just so I don't keep it here. Okay, that. The get window function. And texture view. Okay, we need to find. Let's close all of this. Okay, this is the only function we need for now. So, where do we pass in our light? We do this in probably model, draw light mesh instanced, bind group, oh yeah, we set the light bind group to here. Okay, so let's see, let's open our shader and let's continue. So we need to create a new struct. Let's make it a little bit to the top, right after camera. Yep. Struct light is gonna have a position, vector 3 of f32, and it's gonna have a color of vec3 f32 as well. And we're gonna create group 2 binding 0. Oh no. Var uniform light. Okay. Enough spinning. Basically, what did we do? We got our object color in a specific spot. Strength, we multiplied our light color by ambient strength. Our result is equal to our ambient color multiplied by object color, okay. And we return the result with the alpha over object color. Okay, but we should get something like this. Diffuse lighting. Remember the normal vectors that that were included in our model. The normal vectors. We're finally going to use them. Normals represent the direction a surface is facing. By comparing the normal of a fragment with a vector pointing to a light source, we get a value of how light/dark that fragment should be. We compare the vectors using the dot product to get the cosine of the angle between them. So direction, normal facing up, angle between, okay. If the dot product is the normal and light vector is 1.0, that means that the current fragment is directly in line with the light source and will receive the light's full intensity. Fragment that a value of 0 means that it's perpendicular facing away from the... Okay. We're going to need to pull in the normal vector into our shader.wgsl. Okay, let's see. Our vertex input. Specify our second location. Their normal. F32. And our vertex output. Some new stuff. Location. 1 world normal. That's a vec3. Oops, a vec3. Right, yep, vec3. And location 2 is world position. Oops, world position. Just a vector. I wonder why we need world position. I guess to get it relative to the light. I get a dot product from it. For now, let's just pass the normal directly as is. This is wrong, but we'll fix it later. Yep, and normal mapping. So our var out. Okay, let's see. Let's set our world normal to the model.normal. Normals are cool, but I already talked about that. World position. Two of our model position and 1.0. Okay. Spicy. Why do we set it to... Oh yeah, because matrix is 4-dimensional, that's why we multiplied by 4. That's why we need to add 1, but we only need the XYZ coordinates. Okay. So we return that. And then we get a few more variables. Let light direction is a normalized value between light and position minus world position. That will give us the vector direction. Oh yeah, light direction. Wow, like it's almost like I'm not reading this. Diffuse strength is going to be our maximum value of the dot product. So it's going to be either 1, which is the light source is pointing straight at our fragment, or is it going to be 0? I don't really know why I do max, because anyways it's gonna be... Oh wait, but it can go in the negatives, yeah. Okay, it can go in the negatives, I forgot. And diffuse color is gonna be our light color multiplied by diffuse strength. And I guess we just do ambient color plus diffuse color and multiply all of that. With that we get something like this. Let's see. Error. Oh, I mistyped something, didn't I? Where's the let result? Oh yeah, I forgot semicolon here. Well, this is pretty cool, isn't it? That's a cool light source. It's still not realistic at all, but it's nice, I'd say. Yeah, you can see these parts are dark, and when the object passes, there are some lights there. Let's see how well this works with my model, my amazing model that we made yesterday, which is just a blob. Let's see. We're creating the model here. Yep. Unnamed. Right? It's called unnamed. Oh, untitled. Untitled. Let's see. Okay, it's impossible to see anything. Let me make the distance between them a bit bigger, like 8. Oh yeah, the light model is also the model, so I guess it's looking kind of funky. Yeah, but it also works. It's not that good, because we still have specular lighting to do, yeah. I just had to look in the front. So let's revert this back to our normal cube and continue. So, the normal matrix. Remember when I said passing the vertex normal directly to the fragment shader was wrong? Passing the vertex normal directly to the fragment shader was wrong. Let's explore that by removing all the cubes from the scene except one that will be rotated 180 degrees on the y-axis. Number of instances. Okay. In the loop, we create the instances in rotation. Just replace this with this. Let me comment this out first because I do not want to lose that code. Okay. The light seems to be in reverse. It's clearly wrong, as the light is illuminating the wrong side of the cube. This is because we aren't rotating our normals with our object, so no matter what direction the object faces, the normals will always face the same way. Ah. We need to use the model matrix to transform the normals to be in the right direction. We only want the rotation data though. A normal represents a direction that should be a unit vector throughout the calculation. We can get our normals in the right direction using what is called a normal matrix. Again, normal matrix. We could compute the normal matrix in the vertex shader, but that would involve inverting the model matrix, Wait, we could compute the normal matrix in the vertex shader. Wait, let me open the shader code. But that would involve inverting model matrix. And WGSO doesn't actually have an inverse function. We would have to code our own. On top of that, computing the inverse of a matrix is actually really expensive. Yeah, makes sense, especially because it's a 4-dimensional matrix. Instead, we're going to add a normal matrix field to instance raw. Okay, let's see. Let's go to the end. Our state instance raw. Our normal. Is it? Oh, it's a 3-dimensional one. Okay. We're using matrix 3D instead of matrix 4 as we only need the rotation component of the matrix. Okay. Function description. Oh my god, there is a lot of new stuff added. Okay, so let's see. So 8, I added up to 8. So let's do 9 is gonna be, where is 9? I do not see 9. Oh yeah, I'm blind. So it's gonna be a float 32 times 3. R10 is gonna be float 32 times 3. Oh yeah, it's a 3D matrix. It makes sense. All of them are just gonna be. And this is gonna be a float of 32 times 3 as well. Yeah. 3D matrix. Attributes 7. Okay. We need to modify instance to create the normal matrix. We need to modify the instance to create the normal matrix. So instance raw. We set our model. I don't know why you need to do that. That's still the same thing, right? So on normal is going to be CG math matrix 3 from cell.rotation dot into. Then in our state input, instance input, not state input, we have to add more these. Just copy and paste them there. Everything seems to be. Oh wait, no, we still need to create the normal matrix. Let normal matrix be equal to our mat 3 by 3 of F32 instance dot normal matrix 0 3 2. Oh wait, no, 1 and 2. Okay. So I'm currently doing this in world space. Doing this in view space, also known as eye space, is more standard, as objects can have lighting issues when they're further away from the origin. If you wanted to use view space, we could have included the rotation due to the view matrix as well. We'd also have to transform our light's position using something like view matrix, model matrix, light position to keep the calculations from getting messed up when the camera moves. There are advantages to using view space. The main one is that when you have massive worlds, doing lighting and other calculations in model spacing, it can cause issues as floating point precision degrades when numbers get really large. If view space keeps the camera at the origin, meaning all calculations will be using smaller numbers. This actual lighting math ends up the same, but it does require a bit more setup. With that change, our lighting now works correctly. Nope, it doesn't. Yeah, I'm actually not using it anywhere. Oh yeah. Text chords. Oh wait, normal matrix. Multiplied by model. Yay, lights work. Okay, let's bring back all of our objects. Bam, 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 bam. We also need to rotate them. Let's delete this line. Yep, all the lights seem to work correctly. Let me go to state and search for clear. Okay, yeah, now the colors are a little bit different. Let's see, how well does it actually work? Let's go to our, where are we creating our light uniform? Up here? Nope, up here. I mean down there. Let's see, 0. No, all of them are yellow. This is not a good thing, though. Maybe this will get fixed later on. If you can guarantee that your model matrix will always apply uniform scaling to your objects, you can get away with just using the model matrix. GitHub user shared this code with me that does the trick. Okay, specular lighting. Specular lighting describes the highlights that appear on objects when viewed from certain angles. If you ever looked at a car, it's these super bright parts. Basically, some of the light can reflect off the surface like a mirror. The location of the highlight shifts depending on what angle you view it at. Because this is relative to the view angle, we're going to need to pass the camera's position both into the fragment shader and into the vertex shader. We already have the camera uniform. Oh, it's called just camera? Okay. View position. It's a vector 4. Let's go to our camera uniform. Oh wait, it's here, right? Nope, it's not there because yes, I don't know why it's not there. Our view position is f32 by 4. Oh, just f32. So return a self of view position 0, 0. So you also add the visibility to our fragment shader. Okay. So now in the fragment shader, here we get view direction. Let view direction equal normalize our camera view position x, y, z minus in the world position. Let our reflect direction be equal to reflect what does reflect do? That's a reflect. What could you even do? A reflect direction. Okay, why is it grabbing the negative of light direction then? Okay, let's specular strength. Power of max dot product view direction reflect direction to power of 32. Jesus Christ. Then we set our specular color, specular strength multiplied by light color. Okay, then I guess here we also add the specular color. Okay, let's see how this looks. I misspelled dot. Amazing. Beautiful. Why is nothing showing? I got a typo somewhere. XYZ minus in dot world position. Zero zero power of 32. Specular strength multiplied by our light color. What if we remove the minus there? Nope, nothing changes. Identity into oh, what could be the problem? What could be the problem? is wrong. Okay, let's finish out the code real quick. View direction. What? Up to this point, we've actually only implemented the func part of blink func. The func reflection model works well, but it can break down under certain circumstances. Okay. Why doesn't it cover the issues? Oh, under certain circumstances. Okay, well, I'm not reading this right now. So, I thought it would be like a reference to some article, small one that's just learn OpenGL. Will it work now? Because maybe I was under those certain circumstances. Nope. Okay, let's check out the code. Resources. Nope. Source. Okay, yeah. Let's copy that. Nope. So something wrong with the values I'm passing through. Okay, let's see, where am I? Visibility, fragment, camera bind group, layout. Maybe it has something to do with this? Nope, that's something else. No, and it worked. We already checked. Let's go back to source. librs, and let's go to the very end. Oh, let's go to the very end. Okay. I guess it's not in the very end. It's in the very start here. Where's our light uniform? Okay, here. No, wait, no, we don't need light, we need camera. We need camera. Camera uniform. So 04 self dot view projection camera build view projection matrix. Okay. Maybe that function is incorrect for me. Can I go here? Yep. And let me go into mine. Okay, again, let's do this. Nope. I was switching this up places, it's definitely not gonna do anything. But who knows? Who knows? What? Huh? Why is it? Okay. That's what? Now I cannot see my light source. Alright, Control Y. Where's my light source though? Oh my god, what's wrong with the light now? What could be wrong with my... Okay, let's see, where's the light uniform? Yep, everything seems to be the same. What did I even change? Okay, actually, what did I change? Do you also need to set the view position here? Oh, I know what was happening. We need to have it first, because when we're actually using bytmark on the struct... Oh my god, I'm so stupid. Basically, that happened because we need to use it bytmark and it goes line by line, so it actually put our projection into here and our position into here, which broke everything. Wait. What the hell is that melody? Palmer music! Amazing. Error. So this is our light shader. What's... oh, VEC4. Now we can see the light. Let's just draw the specular light. Let's quickly copy this out and just do specular color. This light seems very intense. I don't like that. Let's see what this is gonna be. Well, this is definitely for tomorrow, not for today. I have done a lot of stuff today. So, yeah. Thanks, I guess, everyone for joining. This is the perfect melody to end on. It's an absolute banger. what is it called? Cabinet Madeline Palmer Edition. Yep, love it. Okay, so anyways, thanks everyone for joining. We ended up making some really nice light sources. I mean, not really nice, just a normal, the most generic light source ever. But we did do it. And before that we spent an hour and a half converting from winit to GLFW. So yeah. Actually, let's see. Does it still have the same problem? No. Yeah. It's better. Oh. Well, let's just not think about this. Anyways, thanks everyone for joining in on the stream. I highly appreciate it. Hopefully I am gonna see you tomorrow because we're gonna be doing normal mapping. And then I guess we're gonna be doing this, and then I'm gonna start actually working on the engine. Isn't that exciting? In my opinion, it's exciting. Okay. Goodbye, everyone. Thanks for coming.